When we multiply numbers like 3 times 2, which is the same as 2 times 3, which we know is 6, that's pretty simple. That's a kind of multiplication we've known for quite some time. But what if I wanted to multiply vectors? What if I had vector A pointing this way and vector B pointing some other way, and I want to multiply them? What does that even mean? Well, there are a number of ways we could define multiplication in that case, and the one we're going to talk about today is often called the dot product. Product because it's multiplication, and dot because we use a dot to represent it. So here's the definition of dot product. A dot B can be calculated in a couple different ways. A dot B can be called the magnitude of A times the magnitude of B times the cosine of the angle between those two. So that's one way of multiplying vectors, and we're going to see it's often very useful in physics to multiply vectors in this way. Not only this way, but this one's particularly useful. And another way to multiply these would be A dot B can be the x component of A times the x component of B plus the y component of A times the y component of B. And if we had a z component, it would be plus the z component of A times the z component of B. But let's stick with 2 dimensions for right now. So one way to look at this is that what we're doing is seeing how much of A is parallel to B. Let's do that. That's called a projection. So I'm checking dropping a perpendicular line down to B, and then A cosine theta is this amount right here. So I'm multiplying the part of A that's parallel to B times B, and that's what this definition means. So let's check a couple examples and see if these two are equivalent in at least one example. You can prove that these two are equivalent, but that's beyond the scope of this video. We just want an introduction to how to use this product with 2 vectors. So let's look at an example. So here I have 2 vectors, vector A and vector B, and let's take a look first at their components. So vector A, it looks like I'm coming over 1, 2, and up 1, 2 on my coordinates here. So this is the vector 2, 2. And this vector B is the vector 2, 0. Let's use our first definition. Actually, let's use our second definition first. We're going to take ax bx plus ay by. So my x components times x components, I see that a dot b is going to be, let's keep our vector notation there, is going to be the x component of A times the x component of B plus the y component of A times the y component of B. So what's the x component of A? That's 2. For B, that's 2. Plus the x component of B, 2 times 0. So A dot B is going to be 4 plus 0 is just 4. So let's check this out with our second definition of how to multiply these two, which says that A dot B is going to be the magnitude of A times the magnitude of B, meaning the length of those 2 vectors, multiplied times the cosine of the angle between them. So what is this angle here? Well, I see that I've gone over as far as I go up, so I know that that angle is 45 degrees. Or, what would that be? If I go halfway around the circle, how many radians is that? That's pi radians. So this is going to be pi over 4 radians for you radian fans. So let's check out what this is. What's the length of A? Well, the length of the diagonal of a 1 by 1 square is square root 2, so this is 2 square root 2. And the length of B is pretty obviously 2. And cosine theta, cosine 45 degrees, is square root 2 over 2. So let's check that out. These 2's cancel. And I have 2 times square root 2 times square root 2. That sounds like 2, and 2 square roots 2 is another 2. So that gives me 4. So indeed, we have the same result using both our methods here. And that is an introduction to dot product and how to use it to multiply 2 vectors.